Welcome to the new NARGESA's folding tutorial video. We will show you how to make different parts and types of bending, such as air folding, deep folding, folding without marks, and even metal sheet rolling or calendared. We will also demonstrate how to choose the punches and dies, how to program the CNC, and how to interpret the tables, folding along with the points to take into account to achieve optimal folding operation. All NARGESA machines have been designed, machined, and assembled in our facilities under strict quality controls. We will begin this tutorial clip showing how to obtain this 6-part fold, all of them at least 90 degrees. Before starting to fold, it is essential to check this chart to determine the opening of the die that we must use. In this case, we know that the thickness of the sheet indicated with the letter E is 2 millimeters. For this thickness, it is to be used a V of 16 millimeters. The letter H indicates the minimum folding flap, or minimum folding length, 10.4 millimeters. In this case, it is enough, since the minimum flap of the piece is 12. The letter R indicates the theoretical internal radius that we will obtain. With 1 meter length, we will need 16 tons to make the folding, bearing in mind that it is a mild steel sheet, with a hardness of 45 kilos per square millimeter. Now, we select a punch that allows us to make this geometry. If the punch, or the die that we have chosen, does not allow us to make the part we need, the control of the machine will indicate a breakdown or collision as soon as we make the program run. To create the program, we select New Program, New Graphic. Then we fill in the fields with the data we have taken from the drawing and the chart. We know that the width is 1,000 millimeters and the thickness is 2 millimeters. As for the resistance of the material to bend, we will select values between 31 and 50 to work iron or carbon steel. Normally, it is 45 kilos per square millimeter. We choose a die out of our library based on the marked requirements. For these parts with little distance between bends, it is advisable to use a die in T, because it is higher and narrower, so it will avoid collisions. The reference of the die gives us all its features. The first figure tells us its height. The second one indicates the opening of the V, and the third one, the minimum degrees of the fold. We put it in. Then we select the punch, taking into account its characteristics. The first figure indicates its height. The second tells the minimum degree of the fold, and the third, its radius. We insert it. We begin to insert the dimensions of the geometry by one of the two ends of the piece, with the links indicated in the drawing. We insert the information in the fields in the upper right part of the screen. By default, it shows a distance of 20 millimeters horizontally. We press the up arrow on the CNC to indicate the direction of the first section of the piece and enter its height into the field L, 12 millimeters. The next section is towards the right. We indicate it with the pointer by pressing this arrow. We introduce its dimension in the field L, 25 millimeters. The next section is down, indicated by the cursor arrow. We introduce its size in the field L, 58 millimeters. We press the arrow to the right and introduce the 30 millimeters in the field L. Then, we proceed with the arrow pointing upwards, 58 millimeters. We continue with the arrow to the right, 25 millimeters, and finally down to 12 millimeters. Then we press the Calculate button, and the simulation appears on the screen. We press Optimize, and the CNC performs the calculations to find the optimal solution, avoiding collisions and reducing the number of operations. The CNC will indicate when it finds the solution. We confirm and press Simulate, so we can visualize the whole process in the simulator step by step. It also shows us the development, which means the total length that the sheet to fold must have, the number of upsettings, and the rotations that we will have to make during the folding process. We save the program in with the name Demo 1. We accept, then we press the button Programming to display all the features of this part on the screen. We place and fix the punch and die to the press brake. We adjusted the lasers 8 millimeters below the punch as a safety measure. We unlock the emergency stop button, reset the safeties, and operate the machine in manual mode. For achieving a proper operation and durability of the punch, it is essential to fix it correctly. We activate the machine in automatic mode to execute the program. As we make the folds, the screen shows how to place the metal sheet for the next operation. This symbol indicates that we introduce the plate by the same side that we are already folding. We continue on the opposite side of it. To finish, we rotate the piece, introducing it by the same side that we are working. We use the same procedure to program this part. We select New Program and New Graphic. We know that the width is 1000 millimeters and the thickness is 2 millimeters. The resistance of the material to bend is 45 kilos per square millimeter. We choose the same die and the same punch as in the previous parts because the minimum distance between folds is still small. We confirm. Then, we put in all the sizes of the geometry in the corresponding fields. We will start at the bottom end of the piece. We insert the dimensions of the first section, 50 millimeters. In the cursor window, we press the down arrow to indicate the direction of the fold and enter its height in the field L, 30 millimeters. The next section is to the left. We indicate it with the cursor by pressing this arrow. We introduce its dimension in the field L, 110 millimeters. The next section is up. We indicate it with the arrow. Next, we introduce the dimension in the field L, 185 millimeters. We press the arrow to the right and introduce the 110 millimeters. We proceed with the down arrow, 30 millimeters. Finally, with the arrow to the left, 50 millimeters. Now we press the button Calculate, and the simulation appears on the screen. We press Optimize, the CNC finds a solution, and we confirm. Then, in order to see the whole process, we just press Simulate, and it will run from the very beginning. The development will allow us to know that we must cut the metal sheet to 541.73 millimeters to be able to fold this piece with these dimensions. In the process, we will make one turn and one rotation. We save the program on the disk with the name Demo 2. We confirm. Then we press the button for Automatic Mode to execute the program. There will be some moments, and due to the tolerance of the materials, when it is possible that the folding angles need a correction. To correct this disparity, we will insert, in the corrections field of each fold, the number of degrees that we need to correct. In this case, all the folds have been at 91 degrees. We will enter the value 1 negative in the first fold, and we will use the arrow in the menu to go to correct the next fold and so on until we have the 6 bends corrected. We will replace the punch and the die to make the calendar operation. The calendaring is a type of folding that allows to obtain different bending radii in a sheet from multiple sequential bends. We introduce all the information of the material to fold. For stainless steel, we select a value of 50 kilos per square millimeter. We will use a multi-V die because the width of its base will provide us with more stability. We must indicate the slot that we will use. As we have already seen, the optimum slot for 2 mm sheet is the V of 16. Whenever the piece to obtain allows it, we will use punches that work on its vertical axis. These kind of punches have a better resistance to pressure because unlike the previous punch, the axis where the force is made is solid. We proceed to enter the dimensions of the piece by pressing the up arrow of our keyboard to indicate that the first section is vertical. In order to program the calendaring operation, we press the Bumping a Radius button. By default, we see this direction of 90 degrees, a radius of curvature of 15 millimeters, and a distance between each fold of a sequential pitch of 3 millimeters. We enter the data for our calendaring. The direction is already correct. As for the curvature radius, we enter 40 millimeters. And finally, we put a length of 5 millimeters between fold and fold. We choose this length depending on the type of finish we want. The less distance we leave between the folds, the better the curve will be defined and finished. In those cases in which it is possible that the sheet does not get to be placed correctly and falls, we can use the support of the gauge needles to hold it during this operation. This eases up the folding process. In this sequence, we can clearly see the function performed by the gauge supports needles. They hold the weight of the sheet and act as a stand, so the handling could be easier and smoother. We place the swinging die with springs to make bends of 180 degrees. These dies have got two folding areas. In the first zone, we perform the previous folding, obtaining a more closed angle of 90 degrees, and in the second, it makes the Dutch folding to 180 degrees or crushed down. We are going to make this especially complicated piece, and we will check that it is really the control of the machine, the one making all the job. If we want to program this type of folding, we proceed in the same way, entering the material information. We insert the die of 26 degrees and with the one V of 10, indicated for sheets of 1 mm. To be able to do the deep folding, we must use a punch with the same degrees as the die, in this case, 26 degrees. To define the deep folding operation, we select the Dutch folding option and insert a 60-degree angle in the alpha field. This will be the first one of the two folds. The second one will always be the deep fold, so it's all the way through. We continue with the 50 mm length until the next bend. We indicate that this fold is diagonal to 45 degrees by using the cursor arrows, and that it has got a length of 30 mm. We also specify the direction of the next fold with the arrow of the cursor, forming an angle of 90 degrees. In the next deep fold, we proceed in the same way by pressing this button and indicating an angle of 60 degrees. When we order the machine to make the optimizations, the CNC has control on the gauge movements. We observe perfectly the movements of the x-axis of the gauge on the simulator. This x-axis is the one that moves forward and backward. We can also get to see the movement of the r-axis, which moves up and down. The Press Brake CNC calculates and performs automatically all small movements of the gauge. If it senses that the piece will collide with the rear gauge while making the folding operation, it will move it away some millimeters to avoid this collision. The roller V die is the ideal tooling to solve the folding with a minimum flap. Its shape adapts to the piece while folding, spreading the pressure evenly. In this way, we obtain results that would be impossible to achieve using a single tooling. The shapes or holes in the sheet become a shortcoming as well as when they are inside or near the working trajectory, because the folding process would deform any cut or hole on the sheet that is on the working line. The finished qualities of this type of folds are perfect. We can see it in the following examples: a folding operation using a conventional die and the other with the roller V die. There is the same problem with the minimum flap in diagonal folds, which we can solve if we use the roller V die. The characteristics of this die are optimal for folding polished stainless steel sheets, so we will obtain a marks-free folding result, 100% guaranteed. The length of the fold of the MP3003 CNC enables us to place several punches and dies to perform different operations at the same time, which opens up the door to different workstations so all the piece will be finished in a single manipulation. In the first zone, we will make the fold of the minimum wing with roller V die, and in the second zone, we will perform the fold with a punch for a big radius. These punches are fixed to the end that can be placed on the machine and allow us to make these bends with different parameters just by changing the end of the punch. All punches and dies can be supplied on its sectioned version. This feature is essential to develop parts with 2 or more sections, such as trays or boxes, in which the folding axes are perpendicular. We put the anvils in both ends. Its shape, with longer length in the lower part, will allow us to make the folds that will close the piece. We select the different sections of the punch in such a way that their total length is less than the size of the largest fold. In this case, the largest fold is 400 millimeters, and we will place the punches so that their total length is 390 millimeters. We will always bear in mind the largest fold, because like that, we will make sure that the punch length is enough to perform all the folds of the part to obtain. For the programming of the folding of boxes, we will generate two sections. For inserting the information, we can begin by either of the sections indistinctly, because it will be the CNC, the one indicating the order of the folds. In this case, firstly, insert the dimensions of the 400 mm section. It uses a T-shaped die with a V of 10 mm, mostly recommended for 1 mm thick sheets. Once we got all dimensions inserted, we press the button Add Section and then the button General Data. It shows up a chart we must complete with the data of the second section. We will only modify the length because the other information is the same as in the previous section. We proceed to the introduction of the dimensions. We press Calculate and then Optimize. The CNC will indicate that we have found a solution. Press Simulate to see the process. The simulator indicates the development and the section number at all times, section 1 of 2. We confirm to see the simulation of the second section of the piece. Like in the previous pieces we have made, it shows the development and the section number, 2 of 2. On this part of the process, we can see why we use the horns to fold boxes. It would have been impossible to make these last folds since the side parts that we have already folded would have collided with the punch. For the folding without marks with a conventional die, we suggest the use of this protective film that we place on the tensors that fix, at the same time, to any die. This material eliminates friction between the metal sheet and the die, obtaining a result without marks, optimal for stainless steel, aluminum, and delicate materials such as brass and copper. It is essential to add up the thickness of this plastic film to the sheet thickness in order to program the piece where we will use it. We check that once we have removed the protective plastic film, we really obtain a folding without any sort of mark. The Press Brake MP3003 CNC NARGESA has a welded frame, stabilized, and with a high-precision machining. The large neck enables the folding of large pieces. It has LED lighting incorporated in the folding area, centralization of all hydraulic components in an only single block. One laser security barrier is also integrated as a safety device. The clamping system for the punches is Promicam, sliding arms for an optional support of the sheet. Folding side doors to facilitate the change of tools, multilingual interface with more than 20 languages available. In this chart, we will show you the different axes that can be incorporated in the press brake. These axes can be activated manually or automatically. The X and Z axes are supplied as standard with the machine. These two axes are enough to make a large number of pieces. However, sometimes the geometry of the piece to fold requires the use of the R axis. This axis allows us to use the gauge at different heights in a much more dynamic way to perform the operation. The incorporation of this model to the machine implies, most of the times, the main difference between being able or not being able to obtain one piece. The powerful CNC control ESA S630 is the core that rules all the systems and solves out the most complex bends. All this features allows any untrained operator to use the machine because the control is the one that calculates whether the piece can be made or not. It also programs the fastest sequence, counts on the gauges and indicates, at all times, the movements and steps to follow by the operator. This press brake MP3003 CNC NARGESA includes an Ethernet port that will make possible any control, management, software update, and diagnose locally and remotely. With the explicit customer's authorization, any NARGESA engineer will be able to access the machine from a distance, which will represent an increase and improvement on the after-sales service and technical assistance of our brand, NARGESA offers in all the machines that we manufacture. Thank you for choosing our brand.